On Earth, the speed of sound has been measured to be a constant at 343 meters per second. This is a number that most of us have studied in school physics, and what it means is that sound waves basically travel at the speed of 343 meters every second. On Mars, it turns out the mechanics of sound is quite different. Planetary scientists working on NASA's Perseverance mission have discovered that on the red planet, sound actually has two speeds, and furthermore, the speed of sound depends on its pitch. I'm Sandhya Ramesh, and this is Pure Science. NASA researchers working on the Perseverance rover on Mars and the Ingenuity helicopter there have discovered that the sounds heard by the rover zapping rocks with its laser travel a bit faster than the sounds made by the low hum of the Ingenuity helicopter. Both the vehicles are a part of the Mars 2020 mission. Ingenuity is the first helicopter on another planet capable of powered flight. Perseverance is probably the most sophisticated, expensive, and advanced scientific laboratory that has ever been sent to Mars. The mission landed on Mars over a year ago, and its objectives are astrobiological in nature. This means that the rover aims to understand the ancient environment of Mars back when the planet had a viable atmosphere, whether it was capable of harboring life back then, whether it actually did, and other questions relating to the habitability of Mars. In the process of understanding all of this, scientists of course need to understand the atmospheric composition and the surface composition of the planet. Perseverance, the rover, has two microphones on it. One does not work entirely as expected. It was actually supposed to record audio during the entry, descent, and landing phase, but did not work. Now it is turned on once in a while to listen to the rover's vital body sounds. The other microphone on the rover is a part of the SuperCam instrument, which is a mix of cameras and different sensors. These are used to visually observe and analyze materials on the planet's surface. The laser instrument zaps rocks, and the microphone on the SuperCam instrument hears these sounds and records them. This helps determine the thickness of the rock that is being targeted by the laser. While these microphones have a very specific scientific purpose, they also pick up ambient sounds. The SuperCam mic was able to pick up the sound from the Ingenuity helicopter, which is about 100 meters away from the rover, for a safe flying zone. By hearing the sounds from the laser zapping and then from Ingenuity 100 meters away, scientists were able to compare the properties of these two sounds. Both of them have a different frequency. The sounds from the laser hitting its target spot on a rock creates a clicking noise. Scientists working on this know when the laser fires precisely, and they know how far away the target is, so they can measure the speed of sound here. The sound of the laser firing at a higher pitch was found to be traveling at a speed of 250 meters per second, while the lower pitch hum from the helicopter that was farther away was on average traveling at 240 meters per second. Both readings are of course much lower than the speed of sound on Earth, which is 343 meters per second. It's easy to see why. Sound is basically vibrations traveling through matter. As the source emits the sounds, molecules around it start to vibrate. These vibrating molecules come in contact with other molecules and get them to vibrate and transfer this energy. That is the basic physics of the propagation of sound. Sound propagates as acoustic waves or pressure waves. The propagation of sound waves is affected by the intricate relationship between density, pressure, and temperature properties of the medium. Sound travels faster in solids than in fluids because molecules are closer together, for example. So the behavior of sound waves or pressure waves is a property of the medium. Of course, there's no sound in outer space where there's vacuum. On Earth's surface, there is atmosphere. On Mars, the atmosphere is very wispy, so there are fewer molecules in the air to carry the sounds. So the speed of sound on Mars in general is slower than on Earth. And then there's pitch. Pitch technically is a musical property. It is perceptual and it is psychoacoustical, which means it depends on how we interpret the frequency of incoming sound waves, and we basically use pitch to compare two different notes or sounds. Pitch is not a fixed quantity, but frequency is. Even in music, if the pitch is, say, the middle C on the piano, it is still calibrated to 261.62 Hz. That's the frequency of the middle C pitch. Frequency is constant. Higher frequency sounds vibrate more, consume more energy, attenuate quickly, and have smaller wavelengths. They typically travel shorter distances. Lower frequency sounds have longer wavelengths and can travel really long distances, such as on Earth, the calls of whales or the stomps of giant elephants. On Mars, what is responsible for this dispersion of sound or variation in its speed is carbon dioxide molecules in the atmosphere. Martian atmosphere is very thin, but it is not negligible. There are active weather processes on Mars, and whatever air is up there is made up almost entirely of carbon dioxide. So these researchers, through their analysis of their 4 hours and 40 minutes of Martian sound samples, which also included sounds from air turbulence, wind, rover machinery, by the way, the authors identified changes in how sound behaved above and below 240 Hz as affected by the carbon dioxide-rich atmosphere. Such acoustical experiments, simple ones such as listening to just ambient sounds like these, can help scientists understand things like air and wind turbulence, which in turn helps understand weather processes, which also then aid in understanding of surface and air composition on the planet. This helps us understand more about the evolution of the planet and thus, of course, of our own Earth. With just simple acoustical samples, the authors have shown that alien planets are truly alien. Actually studying them in detail right down to their basics shows us how different they are from the only planet that we are habituated to.